Hi everyone, this is Vijeta here. Um, Very interesting presentations yesterday in the class. Very interesting discussions following those papers. Interesting questions. Very interesting class. Extending our discussions in the class, I'm today presenting one paper that was published in ACL 2022. So pretty recent work. And the main idea of the paper is that with the current available metrics for measuring bias, the paper actually investigates whether all of these available metrics are actually in agreement with each other or not when they are set to measure the same kind of bias. So that is the main theme of the paper. Now, I'll keep going back and forth between the presentation file and the paper file because there are some details which are not there in the paper and that are actually important to understand. So I just, from my understanding, I have filled those gaps and would like to go through those details in these slides. So the background of this work is that so we have this paradigm in NLP that we pre-train our model and then fine-tune on some task or whatever application that we are working with. And now during pre-training and fine-tuning, our model actually sees a lot of data. And in this data, there might be some word co-occurrences that our model learns, but these co-occurrences might not be, justified. These are the biased co-occurrences that model learns during pre-training or fine-tuning. But what we want is we don't want the model to generalize this learned biases to whatever downstream task that we are working with. Just to give you an example, it could be that say our model goes through data and learns that scientists are, say, boring, and then it sort of like tries to maybe write an essay about scientists. So the essay will be totally biased towards, scientists are boring, they're not interesting people. But what we want is a just description of the scientist term. So for any given downstream application, we want our model uh, to exclude those unjustified word co-occurrences. And it is important. So given that we actually pre-train and fine-tune for any given application, uh, we sort of assume that there is bias in our language model, and these metrics help us to measure that bias. So there are different type of metrics present to measure different kind of biases. So this metrics can be extrinsic method or intrinsic metrics. So intrinsic metrics are the metrics which measures the bias in language model, only the language model part. And extrinsic metrics are the metrics which measure the bias in entire system. And by entire system, I mean there is some pre-trained language model and some classifier for our downstream application. So using this extrinsic and intrinsic methods of measuring bias, the paper focuses on three types of biases: toxicity, sentiment, stereotype, and three type of groups that are usually or very likely to get exposed to the bias, that is gender, race, and relation. And paper sees if extrinsic and intrinsic methods extrinsic and intrinsic metric measured bias are correlated or not correlated. Uh, and the paper actually finds that these values are not at all correlated. In very few cases, we see a positive correlation, and in literally a couple of scenarios, we see some positive and a statistically significant result. So that is the one like analytical setting of the paper, that we want to measure the correlation between extrinsic and intrinsic metrics. And the main contribution authors mentioned that this is the first or an extensive correlation study conducted on intrinsic and extrinsic methods. And their actually key results highlight that these are not correlated, and then they conduct some ablation studies to see or to understand why they are not correlated and what are the careful steps that we should take as practitioners to be careful in measuring our in measuring the bias included in the language models. So authors list out the metrics that has been used in this paper. So there are three types of intrinsic metrics used. So intrinsic again is the metrics which measures the bias in the language model itself. So first is C8, contextualized embedding association test. And again, this is a statistical test, and they measure so if there is a reference text given to language model, what C8 does is that it measures the distance of this reference sentence from two attribute word sets. Now this two attribute word sets could be some positive set of words or negative set of words, negative sentiment, positive sentiment. So these two word attribute sets are polar opposites, and we have one reference sentence. We measure the distance between the positives and the negatives and conduct a statistical test on it and measure the effect size. So effect size itself is the measure of bias for the C8 metric. Effect size is the difference between mean normalized by some value. So yeah, I've just made a note of this, that an effect size can be computed differently for different statistical tests, and mainly the normalizer actually changes and the numerator actually stays the same, that we want to see how different these two groups are. So we take a difference between mean and normalize it by some factor. So we can actually go and if you're interested, you can go in this original paper and see what kind of normalizers they use. They have mentioned what kind of tests they conduct. The other metric is the increased log probability score. This is basically to provide a hard form to the model, and based on how the sentence is completed or how the masked word. So if you see here, a prompt is provided to the model, and based on how the masked word is filled, we measure the bias. Stereo set is another intrinsic metric, and it's a data-based metric. So there comes a data set with the stereo set, just like I think how prompts are provided in this metric. Stereo set provides a list of pairs of sentences. In every pair, there is one biased sentence and there is one unbiased sentence. Based on what model selects, they calculate the proportion of pairs which have been termed, or which proportion of the pair in which model selects the bias term is the metric of bias in stereo set. Jigsaw toxicity has the collection of comments from, I believe, Reddit, and there comes a label associated with the every comment, whether it is toxic or toxic or not toxic, and that's how you train your I think you fine tune your model on this data set and measure the number of true positives and false positive, and based on those true positive false positive rates, we calculate the, I believe, the equalized odds are calculated based on these results, and the equalized odd itself is the measure of bias. Hate explain is the same as toxicity or toxd metric. It provides a data set. Instead of comments, now it is a speech, and there is a label associated with it. And similarly, odds are calculated, equalized odds are calculated, and that is the measure of the bias. Bold dataset actually provides set of prompts, and these prompts are actually segregated according to whether those are sentiment related prompts or toxicity related prompts or regard or stereotype related prompts. So what happens is that we in case of bold, we provide this prompt to the model, and based on how model completes this sentence or provides a generated text, based on that text we measure the bias, and that is the score, bias score for a bold metric. And all of the bold metrics actually start with B, so it is actually just helpful to keep that in mind to interpret the results later on. All right, so these were the metrics considered in the analysis. Now the correlation setup. So this is where I felt the paper actually lacked a lot of details, and that's why I actually created this slide. We can go. So based on my reading, my understanding about the correlation setup is this in this slide. I'll explain it step by step, and then if we have any questions, we can later on discuss it in the class, or you can also shoot me an email about it. All right, so in the paper they just say that they conduct a correlation test, but it is important to understand what are the variables, how the variables are measured, and what is the hypothesis and everything. So these are my guesses about the variable definitions and how they are measured. Okay, so we have three types of biases: toxicity, sentiment, and stereotype. We have three protected groups: gender, race, and religion. Now, what we want to do is that for every protected group, we want to measure one specific bias, right? So we have one pair that is fixed. Now, how we measure this bias for a specific group is that we fix a language model and then provide some sentence to it based on the output, and based on one metric, we calculate the bias for this pair. Now, what things are fixed here? So one is language model is fixed, then the toxicity type of bias is fixed, then protected group is fixed. All right. So now if we focus on the table, let's consider that there are, so in the analysis they have considered 19 different language models. So these are the 19 different values, or the variable measurement happens 19 times for this every single language model, and we have two different type of variables here. All right, so what is the first type of variable? So let's consider that the first type of variable is related to all intrinsic metrics, and the second type of variable is related to the extrinsic metric. All right, so what we fix here, we fix the type of metric used. The first subscript corresponds to the model, so we fix the model. The second subscript B is the type of bias we consider, and the third subscript G is the group that is exposed to bias. So if we take the example of toxicity and gender, it will be X intrinsic will remain some metric, intrinsic metric 1, then B will be toxicity, and G will be gender. All right. But there is another actually small detail that they have mentioned in the paper, that for every group there are subgroups. For gender there is male, female, and other non-binary identifications. In race there will be white, black, Asian, African American. Those are the races present, and it depends on like analysis and the data set which subgroups are present there. So the ultimate value X. So now we have seen actually the what is the superscript and subscript actually mean. The X here is the final representation of the bias, right? So what is X? So we have a metric that is fixed. With that metric, the language model, the type of bias, and the group, what we measure is the bias measured from that specific metric for all of the subgroups. So if we consider gender, it will be subgroups will be male, female, and other non-binary identifications. For every subgroup, we measure what is the bias metric, bias measure with the help of some metric, and we calculate variance over those values. Paper says that if the variance is low, your model is fair, which makes sense, right? So if all the values of the all the bias values are close together, then yeah, so all the bias measurement, if they are close together and variance is low, we say that okay, model is producing the same result for all of the groups. And when the variance is high, it means that the bias measures for different subgroups are different. So model actually looks at different subgroups in a different way, and that results in a high variance, and that means the language model is biased. So that is the interpretation of this x value, that is the variance over different bias among the subgroups. So we have this now. Now variable 1 will be intrinsic and variable 2 intrinsic, and we have 19 values for each of the variable based on the 19 language model considered in this analysis. All right. So that is my understanding of how the variables are defined and how variables are measured. Now this is set to go in one correlation test. Now that they mentioned that the correlation test is conducted, but the hypothesis, the confidence level, those details are missing from the paper, which I think are really helpful to understand what was their null hypothesis. Was it that there exists no correlation? So for example, Pearson correlation coefficient is the test statistic. So is there null hypothesis Pearson correlation is equal to 0, or is it the null hypothesis that the Pearson correlation is less than say 0 or 1? So those details are actually missing from the paper, and it would have been better if that was present. In the results, let's look at the only one value for just giving you some context. So our bias group is gender, and let's say the type of bias we are measuring is the toxicity bias. So we fix the group and the bias, and we measure the intrinsic bias with C8 here, and the extrinsic bias with ToxD. ToxD is the label dataset that we have from Reddit, and we can see the value is negative. That means that whenever we measure the bias with C8, that those values are not correlated with or actually negatively correlated with the ToxD measured bias. So whenever say for a model, actually I'll later on I'll come to that point, but anyways, so if we see C8, it is generally not in correlation with the extrinsic metrics for the gender group. ILPS, on the other hand, has the most positive correlations, and the bolded values, authors mentioned that those are the statistical significant results, but we don't know what is the confidence level there. So they just measure that, okay, they just mention that those are the statistical significant results. In case of race, we see half and a half, that few values are positively correlated, few values are negatively correlated. In case of religion, we see in ILPS is consistently negatively correlated with all the extrinsic metrics, and C8 mostly is positively correlated with the extrinsic metrics, but just besides the B-cent value. B-cent is the prompt-based measurement. The last type of bias they consider is the stereotypical bias, and we can see all of the values are negative, but just one. In case of religion group, if we measure stereotype with the B stereo, then those values are positively correlated, but others are negative. Now they mention that okay, we see that there is no correlation between extrinsic and intrinsic values. Now, how do we actually correct this in practice, right? So we get some idea that okay, these metrics are not in correlation, but why those are not correlated, and what steps can we do to um, align both of their values together. So they conduct like a lot of ablation studies for answering those questions. First ablation is that instead of taking the vanilla definition of the C8 metric, they manually define the attribute sets. So remember, for C8 there are two attribute sets. One is positive, one is negative. So what authors do is that they alter this positive and negative, which are aligned to toxicity measurement, and then conduct the correlation study again. In that case, you can see here in this table, most of the values are positively correlated. That shows that okay, we cannot use the directly given definition of the metric. We need to maybe alter some things here and there to align the intrinsic and extrinsic metrics together. The second ablation is the how protected groups are actually defined. Actually, I'll go back to the paper now. So the first we saw that how misalignment on notion of bias is, if we alter that, then the positive correlation can be seen between extrinsic and intrinsic. The second is that misalignment between the protected groups. So authors actually consider just filter out data sets that are used to measure the racial bias, and they focus on only the groups that are common to all of the data sets, and then conduct the correlation study again. So basically they align the protected group definition for both of the intrinsic and extrinsic metrics and measure the correlation again. So they see the correlation strength increases, but you can see the p-values, huge p-values, so we can't really conclude anything on that. And even in the second set it goes to 0.08, but that strength itself is quite low. The third is misalignment on evaluation set. So authors mentioned that there can be wait okay, I see. So in this ablation, what they're doing is they use the examples given in the stereo set data set, and develop prompts from those examples, so that the um, the evaluation set for intrinsic and extrinsic metrics is the same, and then conduct the correlation. They see the strength increases from -1.8, -0.18 to 0.02, and the p-value again here is 0.98. So inconclusive results, but even if we consider this to be statistically significant, the strength, the final strength is 0.02, which is not that great, very close to zero. So again, neutral correlation between intrinsic and extrinsic. Noise in the evaluation set is where authors mention that there can be bias in the evaluation data set. So if we take closer look in the evaluation set, remove the bias, and then again conduct the correlation analysis, what happens? So they see that there is an increase of correlation between C8 and B cent from -0.42 to 0.11. This is a great improvement, but they do not at all they're not at all present the p-values for this one. The second is that they mention that I'll go here. So stereo and B stereo increases to 0.10, but that actually is just stereo set and B stereo relation is 0.10. So I don't know. They just mentioned that it increases from 0.10 to 0.10. That doesn't make sense. Uh, and last two ablations were actually regarding how the inference setting of the model can affect the measurement of bias. So now we have seen in the prompt related papers that hard prompts are the setting of hard prompts is quite sensitive to the model results, right? So as soon as we change the setting of the prompt, it's going to change the results by a large amount. And the authors actually mention this point that we can actually see a lot of differences between different inference settings. So first, that changes the temperature parameter of the GPT-2 model. They changed the parameter from 0.5 to 1 and mentioned that the negative sentiment assignment increases from 4.6 to 15.6. So this is related to the bold dataset. So bold dataset is prompt. Given that prompt, model completes the sentence and we measure the bias of the completed sentence. So the negative assignment in this completed sentence increases from 4.6 to 15.6. I am not very well accustomed with this temperature setting of GPT-2 and not able to interpret the results like how bad or how good this 4.6 or 15.6 change is. The last ablation is about impact of noise in the generated output. So again, we take the bold data set, we provide the prompt, we complete the sentence. And in the generated sentence, author actually swap a few words or they delete few words and then measure the bias. But when they say that they want to measure the change in the bias measurement in the inference settings, I don't understand why deletion or swapping of already generated words could relate to the inference setting. And if we take any kind of text and swap and we want to measure the bias in that specific text, it might be just some chunk of Wikipedia or model generated text or whatever. If we swap or delete few words, the measurement is going to change for the bias. So I don't understand why they have done this ablation to show the negative association of their sentence generated increases with deletion and swapping. So overall, the conclusion is that the current available metrics are not correlated to each other, but in my opinion, the most important takeaways from this study is that selection of bias metrics is important. Like depending upon the task that you are dealing with, you have to be careful in selecting the metric that you want to use for bias measurement. Also, the vanilla version of this metric definitions might not be as useful for our specific task. So we have to modify how the bias is actually measured compared to the vanilla versions of this metric. Alignment of definition of bias and protected group is also important. So yes. And the last one I would say is the bias in the evaluation dataset also affects the agreement between intrinsic and extrinsic bias measurements. So we have to be careful while looking at the measurement dataset, and we might want to take a look more closely and remove if there are any bias already present in those datasets. Weaknesses of this study, I think the meat part of the study is the statistical test, and they do not mention any hypothesis. They a clear definition and measurement of the variables is missing, and also p-values are not present for all the experiments that they have conducted. In addition, I was also expecting to see the actual variable values So 19 values of extrinsic, 19 values of intrinsic, maybe in the appendix or somewhere, but that is also missing. Uh, in ablation, they show that the correlation strength increases, but p-values are inconclusive. Inference configurations are so they show in ablation that inference configuration matter, but they do not show inference configuration for their base case results. uh, Effect of fine tuning. So these two are sort of the same. That what I think is the the objective function of the pre-trained language model can affect the performance on different bias metrics, and that should be studied, I think. So for example, the pre-trained objective of BERT is different from GPT, and how that affects the downstream measurement of bias. So if we use the same kind of data set, say classification data set, then maybe BERT will do maybe better than the other model, or if it is generation, then maybe BERT might not do as well as the other models. So those effects are not discussed or studied in this paper, but I think those should have been at least touched upon in the ablation studies. So that's all I have for today. I hope this helped. I'm definitely gone over 20 minutes mark by large amount, but yeah, I